In this video, I'm going to explain for you how to find or evaluate piecewise functions, also how to graph piecewise function. So first of all, let's understand what's mean piecewise function. Dear students, piecewise function is a function that defined by some expression or rules. Each rule, let's say rule number 1, have own condition for this rule. Condition. If we say f of x, so condition on x. And we can have more than one rule, let's say 2, 3. If it's one rule, so it's a normal function, not piecewise. So you must have more than one rule, so either 2, 3, 4, whatever. So rule number 2, so you have another condition on x. For example, f of x equals, we can have two different rules. As example, we can say 3x plus 1 when x greater than or equals 0. And we can say f of x can be another rule, x power 2 when x less than 0. Note that I have for the first rule a condition, and for the second rule also another condition. So for these type of functions we call them piecewise function. So right now I'm gonna teach you how to evaluate piecewise function. Okay, dear students, as you can see, here's two examples for you. If you read the question saying evaluate each piecewise functions for x equals negative 2, x equals 5, and x equals 3. The purpose of picking these numbers is not, let's say, specific numbers. It's just random numbers that you can pick any other numbers to evaluate as long as it's in the domain. So we picked these three numbers as example, and let's get started and solve the question. Okay. So for the first one, when we have x equals negative 2. Dear students, for f of x, let's say part A, negative 2 satisfying which condition? Is negative 2 greater than 0 and less than 3? Of course not, right? Is negative 2 greater than 3? Of course not. So doesn't satisfy these two conditions, right? But it satisfies this condition. You know why? Because negative 2 is already less than 0. Tamam? So when satisfying this condition, you are going to substitute negative 2 in a place of x. Since we don't have x here, if you have a constant or any number, so the value equals this number. So f of x equals how much? Equals negative 5. So we will write f of negative 2 equals negative 5. So the value when you evaluate this function for the value negative 2 equals negative 5. Understand? So if we evaluate for 5, if we want to find f of 5, so students, from which of these conditions, let's erase these, from which of these conditions we can substitute 5? Note that 5 is greater than 3, right? You cannot substitute 5 here because 5 is not between 0 and 3, and 5 is not less than 0, right? So the best place for 5 or condition satisfying 5 was the third one. So when you evaluate 5, so f of 5 equals how much? Equals 12. Tamam? Finally, let's find out 3. So f of 3 equals how much? Dear students, f of 3 we cannot substitute in the third condition. Why we cannot? Because 3 cannot be greater than 3. 3 cannot be greater than 3, right? So this is not a good idea. Also, 3 is not, let's erase this one. 3 is not less than 0. True? 3 is not less than 0. So what we should do? The best place for 3 is what? Is the second condition. Because here we have equal. We have equal condition. So we can 3 can be equal to 3. So the best condition for 3 is second one. So the answer equals how much? Equals 4. Okay, dear students, let's change the color and go for question number 2. Part B. Let's satisfy or evaluate same values for part B, or you can change the values, but for this example I picked these 3 numbers, these 3 random numbers. For the first one, -2, x equals -2. Is -2 greater than 5, less than 5 or greater than 5? So as you see, students, -2 going to be less than 5, so that's why you should substitute -2 in a place of x in the first rule. So we will say f of -2 equals 3 times by -2, replace x by -2 plus 4. So we will get 3 times -2 equals -6 plus 4. Final answer equals -2. So when you substitute -2 in this f, the answer is -2. Okay, this is first one. How about second one? If you have 5, so students, from which condition we can substitute 5? Of course, we cannot substitute 5 for the first condition because 5 cannot be less than 5. So that's why we must substitute in the second condition, so that f of 5 equals, substitute 5 in a place of x, so we will get 5 square minus 3. So equals 5 square is 25 minus 3, final answer is 22. Finally, for x equals 3, dear students, 3 can be replaced in which of them? So 3 satisfying first condition because 3 is less than 5. 3 is not greater than 5, right? So 3 we can substitute in the first condition, so that we will get third one. We can say triple I. F of 3 equals 3 times by 3 plus 4, so equals 9 plus 3. Final answer is 13. Okay, dear students, right now I'm going to teach you how to graph piecewise functions. Look at here. Before, when we had f of x as example equals 4, or y equals 4, y or f of x is same meaning. So we say that the graph going to be a horizontal line passing through 4 on the y-axis, right? But this line can be extended to the right and left all the way, because domain here is all real number. But in piecewise functions, since you have a condition here, you cannot extend this line to the right and left. Should satisfy this condition, which is x greater than 1. Only when x greater than 1, then the value is 4. So when for x less than 1 is something else, is not 4. So let's apply this idea on this graph. So first of all, you need to find out 1 on the x-axis. So this is 1. And the other value, if you have, you can substitute. If not, so we have 4. So find out 4 on the y-axis. Okay, 1 and 4, the point can be here. So here you need to draw a circle. Okay, if you have, look, if you have less than or equal, greater than or equal, you should draw shaded circle. But if you have less than or greater than, you should draw open circle. So here we need to shade our circle because the graph here is equal. So 4. Dear students, here the condition saying x greater than 4, x greater than 1. Which x's are greater than 1? Note that 2, 3, 4, 5, these values are greater than 4. So this graph goes to the side, right? It used to be like this, extending right and left, but right now only when x greater than 1 equals 4. Tamam? For the second one, again, you should find out 1 on the x-axis and -2 this time. So 1, let's erase this part here. 1 and -2. This is 1 we had, and -2. This is -2. Draw a circle. So this is our circle, but we will not shade our circle because here we don't have any let's say equal sign, so that the graph should be open. And the question saying the condition saying x less than 1, so that which values are less than 1, which is 0, -1, -2, -3, -4. So this line goes to the side. So this is a graph of this function, which is a constant function, consists of 4 and -2 with 2 different conditions. Okay, dear students, what if you have x in your rules, not constant, if you have x's? So what you should do for these type of questions, you need to draw a table as the best option. So we have for -3x, we can draw a table. Okay, so the table consists of x and y, so you can pick numbers. I recommend you to pick this number first, 2, in the condition, and more numbers, or one more number, let's say. You can pick more numbers, or if you pick one more number is enough, a number that satisfies this condition. Pick a number that satisfies. We can say 0. 0 is less than 2, yes. So you can pick 0, or you can pick negative numbers as you like. So we will just pick this number. Substitute 2 here. -3 times 2 equals to -6. And if you substitute 0 here, equals to 0 back, right? So dear students, if we graph 2 and -6 on the coordinate, we will get 2 and -6 can be extended more, which I don't have it here. This is -4, -5. You can say -6. So we can have, this is 2 and this is -6. Do we have equal sign? No. We will leave it like that. The other point is 0, 0. So pick 0, 0 also, but put dot. Then join these two points together and extend it. So let's join them and extend the line, so we will get the graph. So this is going to be our graph for the first part. For the second part, dear students, going to be the same thing. This is -6 about y, and this is 2 about x. So 2, -6, this is the point. About second one, we have x plus 3. Dear students, change the color to be clear more. For x plus 3, again make table x and y. Okay, pick number, pick this number again, this is 2, and pick a number satisfying this condition, maybe 3. So we can pick 2 and 3. So substitute 2 here in the function. 2 plus 3 equals 5. How about if you substitute 3 equals 6, right? So 2 and 5, 2 and 5, 2 and 5 about y-axis. So 2 and 5 can be here. So do we shade the circle? Yes, because it's a closed, have an equal sign. Other one is 3 and 6. 3 and this is 3, and 6 can be up of this one. Join them and extend it. So this is going to be the graph of this function. Okay, dear students, final example for this video is going to be this example. G of x equals 3x plus 8 if your condition x less than -3 and -2x given a condition and x squared minus 3. So again, we need to draw a table in order to graph this function. Dear students, let's make graph or table, sorry, for each of them. So for the first one, we have 3x plus 8, right? Let's write more bigger. Let's say 3x plus 8, right? So dear students, to make table for this one, we have x and y. Pick the given value here. So it's -3. So we will pick -3 and a number that satisfies this condition. Which number is less than -3? We can say -4, right? -4 is not less than -3. Say yes, of course. So -4 and -3. You can pick more numbers, but just we pick these two numbers, which is enough. Substitute -3 here when you substitute equals 3 times negative 3, negative 9 plus 8 equals negative 1. And other one, negative 4 substitute equals negative 12 plus 8 equals again negative 4 back. So substitute these values on the coordinate plane, negative 3 and negative 1. This is negative 3 and negative 1 can be down, so draw circle here. Since we have equal signs, so we will shade it. We will shade it. The other point is negative 4 and negative 4. This is negative 4 about x and negative 4 about y, so going to be here. So join these 2 points and extend them. So dear students, since it's a linear graph, so we will join these 2 points and extend them. So here we go. This graph can be go wider. So this is the graph, because this one goes more. About second one, dear students, pay attention. When you have this type of conditions, x between these 2 numbers, so I recommend you to just pick these 2 numbers. For example, for negative 2x, just pick these 2 numbers, no more, no less, because the values that you pick, you must pick the values greater than negative 3, less than 1. So this is, let's say, bounded between negative 3 and 1. So just pick for x negative 3 and 1, no more, no less. So when you substitute negative 3 here, you will get 6, right? Negative 3 times 2 equals 6. When you substitute 1 equals negative 2. So let's change the color. Okay, so negative 3 and 6. Negative 3, this is negative 3, and 6 about this graph going to be here, students, right? So do we shade? No, we will not shade for negative 3 because there is no equal sign here. Okay, we'll leave it open. How about the second part? Again, we leave it open, but let's find out 1 and negative 2. So this is 1 and negative 2. So again, draw another circle for 1 and negative 2, okay, because this is bounded. So join these 2 together, you will get the graph. So this is second part. Finally, students, we have x squared. So this is tricky, be careful please. About x squared, students, when we have x power 2 minus 3, we all know the graph of x squared is parabolic U-shape, right? Minus 3, it goes down, so by 3 transforms so to negative 3.